So we're going to write this as a function, okay, or a linear function. We're going to make it as a line, essentially, that says how far he's traveled and how much gas he's used as he's traveled. So we're going to complete the table of values, and then we're going to graph our values once we're done. So the first part here is just the G, and I've got from 0 to 7. In this problem, what does the G stand for? What? Gas. It's my number of gallons of gas that he has. So this is my independent variable. It's the first one I put in. It's my X variable, essentially. This is my independent one. So I can change the number of gallons of gas I put into my car. The output is what? I put a certain number of gallons into my car. What's the output? What changes? How many miles I go. Exactly. So this independent one is my gallons of gas. And this one over here is called my dependent. And I'm not going to write the whole thing out. A dependent one, and it's just the number of miles that I am able to travel with those, with that gas. Now, 0 is essentially your starting place, right, at the very beginning. So when he first got the car, how many miles were on his 50 odometer? Yes, there were 50 miles, even though he hadn't put any gas into his car. Now, if I put in 1 gallon of gas, how far are you supposed to be able to drive? 30 miles. Okay. So if he already went 50, right, he's already got 50, he puts 1 gallon of gas in, how many miles should he go? 80. Good. So we're adding those 30 miles. If I put another gallon of gas in, 110. Good. I add another 30 to it. Now I'm at 110. If I put another gallon of gas in, 140, and so on and so forth. So essentially you are just adding your the 30 miles, right? So for each gallon of gas, he's going 30 miles. Okay, so it's a consistent, I'm adding 30 each time, adding 30 each time, adding 30 each time. My graph is going to look like a what? Is it going to be a line, or is it going to be the curved one? It's going to be a straight line, exactly. So now what we're going to do is we are going to graph our data, okay? Now, on the x-axis, this is my independent variable. This is your x. That is your number of gallons of gas. So I think we have enough to just do, what can we count by? What do you have to go from on your x-axis? From what to what? 0 to 7, right. So what should I count by? 1. Count by ones, yeah. So this is your gallons. Okay, now my y-axis has to go from 50 to 260. What do you think I should graph by? What should I count by? 20s. You could count by 20s. You could count by 10s. 2s are going to be really hard because you got to go all the way from 50 to 260. That's a lot of lines, and I do not have that many lines over here. Oh, could go by 50s. Let me give you another hint. What are you counting by? What's your number going up every time? Why don't you count by 30s then? Oh, and then your numbers can be exact right on your graph. Now, here's going to be my little trick. Instead of starting at 30, like, you don't have to start a graph at 0. You can put a break in the graph and you can start wherever you want. You could start at 20. You could. Why don't you just start at 50? Right? And then if I'm at 50, if I put a little break in the graph here, so if you ever see, it kind of looks like a little Z. It's a break in the graph. That means you're not starting at 0. You're going to start at your own number. So you could start at 50 right here and then literally go up exactly by 30. So you go 50, 80, 110, so on and so forth. I kind of ran out of room, but essentially you already know you're going up just one each time. So now let's graph it. At 0, you are at 50 right here. And then from there, it should go up in a straight linear line, a constant line, because you're going up consistently by 30. So your graph should look like a line. If you wanted to put all the numbers, you totally can. Kind of ran out of space. Okay, and then I'm going to make it into a line because I could put more gallons of gas in, right? If I ran out of gas, I could put another gallon in. And I could put another gallon in. And another one. So that's going to consistently go up forever. Okay. So now we've got our graph. We've got our independent variable and our dependent variable. Question number 2 says, circle the point on the graph that represents the value of D of 4.5 and explain what this point means in the context of the given situation. So that means I want to take the number 4.5 and I want to plug it in for my G, for my independent variable. So what does 4.5 mean in the context of this situation right here? What are we talking about? 4.5 what?
4.5 gallons.
Gallons of gas. Yes, exactly. So this question's really saying, if I put in 4.5 gallons of gas, how far could I go?
155.
How'd you get that?
It's between 140 and 70. Or wait, it would be 185.
185. Perfect. So if you go 4.5, that's right between the 4 and the 5, and you go straight up, it should be right here. That's what your point is. So this says if I put in 4.5 gallons of gas, okay, so with 4.5 gallons of gas, right, essentially I need to be halfway between 4 and 5. And Nico, what did you do to find the exact number between 4 and 5?
You gotta take the numbers that you have and what's in between it. So
Right.
In between 200 and 170 is 185.
Because 15's half of it, exactly. So that's halfway between these two. So he can drive 185 miles. So this question says, right, like if I plug in 4.5 for the gallons of gas, right, that's my input, I'm plugging it in. I want to know what's my output. How many gallons or how many, miles can I drive with that number of gallons of gas? Okay, so for number 3, using this graph here or using the table, take a second. I want you to determine the approximate values of the following. So if I put in 5.5 gallons, how far can I go? If I put in 3.25 gallons, how could I go? If I put in 10, how far could I go? So look at the table, look at your graph, and I want you to try to answer those 3 little pieces there. Give it a try. So it doesn't have to be exact, something close. Okay, so with about 5.5 gallons of gas, about how far can you go? About 215 what? Miles. Make sure you label your answer. Right, I gotta know what you're talking about. About 250 miles, good. What about 3.25? Didn't do that one. Why?
Oh, man, I could do it.
What'd you get? What do you think? Give me a guess. Come on.
It's 6.5. But does it go up by 6.5?
You can do it that way, yeah. Yeah, so what would you get? So first of all, what two numbers should it be between? If I'm putting in 3 1/4 gallons of or 3 1/4 gallons, about how many miles does it have to be between? Yes.
Is it 147.5 miles?
It is 147.5 miles. How'd you get that, Angel? What'd you do?
By 35. 30 divided by 4. And I added 140.
To that number, right? So he took a quarter of whatever this number was. This change was 30. He took a quarter of it. So he divided it by 4. And then whatever that number was, he added it to the 140. Because you know you're between 140 and 170. So that's the exact answer, about 140, 147.5. But if you put something close to 147, something close to 150, that's fine with me. Because it's not exact, I'm looking for approximate, but something around there. Good. What about when you put in 10 gallons of gas? 350, how'd you get that?
I added on for the X, I added on an 8, 9, and 10, and I just went down.
You just went down by 30. Perfect, perfect. Yeah, so Jay said she just kept going over here with the pattern, right? So she knew that she had to add another couple gallons of gas over here, and so she just kept adding 30, 30, 30, 30, till she got where she needed to be. Perfect, good job. All right, last question, number 4. The statement D of G equals 180 is actually asking you a question. Interpret the question that's being asked in the context of the given situation, and then answer your question using the information provided in the table or the graph. So, in these problems over here, I said plug in 10 for your number of gallons, and I want to know what the output, the number of miles, is that you can drive. This statement here is a little different. It says D of G equals 180. What does that mean? What does the 180 talking about?
Miles.
Okay, so it's saying you can drive 180 miles. What's the question that I want to know?
How many gallons of gas?
Exactly. So I give you this time, this is like your output, right? What's coming out, this is your input, or we call it independent and dependent variables. That means the same thing. So like Nico said, the question essentially is, if you can drive 180 miles, how many gallons of gas do you need? So how many gallons needed to drive 180 miles? That's what I'm trying to figure out. How many gallons so I can drive 180 miles? Now, how would you figure that out? So I know you can go 180. Look at the table. What is that between?
4 and 5.
It's between 4 and 5. So you need between 4 and 5 gallons of gas. Now, is that number going to be closer to 4, or is it going to be closer to 5?
4.
Something closer to 4. So you can give an approximate number. You can round. You don't have to be exact here. How many, by looking at that table, do you think is about needed to go 180 miles? It's going to be 4 point something. What?
4.3.
About 4.3, 4.2. Yep. Well, so I don't want to go halfway because it's definitely, 180 is definitely closer to the 170. So it's going to have to be a decimal. It's definitely below the 5. So you could say about 4.2, about 4.3 gallons are needed. So look at that. You just figured out how to do a linear function from a table and from a graph. Now, in these problems over here, we did a lot of estimates, right? Just kind of looking at the graph, looking at the table. Now I'm going to show you how to do it exactly so that you don't have to guess anymore and you'll get the exact answer every time. Okay. All right. Can I move on, or are some people still writing? Am I good? Wait a second. See some people still writing. Okay, I'm gonna go on to the next part, but I'll come back if you need it, okay? All right, part 2. So that's just kind of our little exploration. It's our introduction to linear functions, is what we're talking about. Now, part 2, slope-intercept form of a linear function. Everybody in here knows what slope-intercept form is, especially my people who are also in geo with me. What is slope-intercept form? Y equals mx plus b. Bringing back some bells, like ringing some bells. Remember that one? Maybe from Algebra 1, maybe from geometry class today, or yesterday. You've got 2 parts of that line. You've got the m and you've got the b. What's that m called? Slope. What's the b?
Y-intercept.
The y-intercept. Hence why it's called slope-intercept form. Get it? Because I gave you the slope and the intercept. Wild. So the m is your slope and your b is your y-intercept. So in your own words, can someone explain to me what slope is?
Rise over the run.
Rise over run. Laura, what were we going to say?
I was gonna say if it goes up or down.
If it goes up or down and then left or right. So slope just means like how steep is your line. If you're going up a hill or if you're going down a hill, right? That's slope. Y-intercept means wherever it crosses the y-axis on a graph. Okay, the y-intercept tells us something very important about our function. It tells us a few different things. It tells us where the graph will cross the y-axis. In other words, the point 0b will lie on the graph. So 0 is your x, so you're not going to move to the right or to the left, but you are going to go up or down. When you plug in a 0, this is called a 0 of the function. So where it crosses the y-intercept, that is something called a 0 of the function. Wow, I spelled 0 wrong. Oh my word. A 0 of the function. So it literally means where it crosses the y-axis, one of the numbers is a 0. Okay. So now we're going to use slope-intercept form when we go to write our equations. And that way I don't have to guess anymore when it comes to my input and my output. It's going to be exact numbers and you won't have to estimate anymore. Okay. So number 1, it says use your data from the table of values you created over here, and then we're going to determine a symbolic representation. So all I want you to do is just copy the same numbers that you had over on the left. We're just copying them down for a moment. So 50, 80, 110, and 170. Okay. So we've got the equation y equals mx plus b. The 2 pieces that we need are the slope, the m, and the y-intercept. Now, you already know where the y-intercept is. Your y, what?
We were going by 30s, right?
Yeah, I just copied the same numbers from over here.
You said 170, it's 140.
140, ooh, my fault. Wow, I'm like off today, eh? Thank you. 140, thanks so much. Okay, your y-intercept is wherever your x value, your input, is a 0. So if I come over here to the 0, what's my y-intercept? 50. Yeah, so when I go to graph it, it's going to be at 0, 50. There's my y-intercept. Essentially, it's just the number 50 that I really care about. The other part we need is the slope. Now, you guys know slope as rise over run, which is what Nico said. We can also do slope as the change of y over the change of x. Have you seen that before? You know, some of you have. Change of y over change of x, which just means how are your y values changing? How are your x values changing? So how much are you going up? How much are you going over? That's all I'm looking for. So in a function, this part's my input, that's my x value. The second one is my y value. We just write it differently. We write it as a function. So if you're looking at your y values, how are they changing? How do you get from 50 to 80? What did we do?
30.
Added 30. So there's my y value. And then how do you get from 0 to 1? 1. So your slope is 30 over 1. Or you can just write it as 30. So now I'm going to take my y-intercept, I'm going to take my n value, and I'm going to plug it into the equation y equals mx plus b. Okay. So the only part you need to plug in is your slope and your intercept. And it's the two numbers we just found. So what would my equation look like for this problem? 30 x plus 50, right? Because if we just have 30 plus 50, then you just got a number. So my equation is y equals 30x plus 50. And that's your final equation. Now, this is how we write it if we're just writing it as a line, but we're writing it as a function, which just means my x variable, instead of x, we're using g for gallons. And instead of my y variable, we're using d of g, which means how many gallons does it take to go this many miles. So instead of writing x and y, I'm going to write g and d of g, but it's still the same problem. So instead of y, I'm writing d of g equals 30g plus 50. Okay, that's it written as a function. Equation of a function. Okay, so now we have exact numbers, which means we don't have to guess anymore. So now what I'd like you to do is, using this equation, I want you to do number 2. I want you to determine the exact numbers for these three, which just means you're going to plug in the number 6.5 for your G. You're going to plug in 4.25 for your G. You're going to plug in 50 for your G, and then solve. Okay, so you're plugging it in. Does that make sense? Okay, so this means D of 6.5 means if I give you 6.5 gallons, how far can you go? So G stands for gallons over here. I'm trying to figure out this one over here, which is how many can you go? So instead of a G right here, I'm going to plug in 30 times 6.5 plus my 50. 30 times 6.5 plus 50. Then you're going to solve it and get a number. I don't know what that is. What did you get?
195.
Whoa.
I got 245.
I got 245. Times 6.5. Make sure it's multiplied. And then you forgot to add your 50. So this one is 245 what? Miles. Okay, can you do those two? Can you B and C? Try B and C. And then we'll see if we get the same answers. Try B and C. All you're doing is plugging it into the equation. Make sure you label your answers too as miles. Okay, what did you get for B? 177.5. Nope, keep it exactly how you see it.
Oh, yeah.
Because it's miles. So you can go half a mile. Good. And what'd you get for C?
1550.
1550. Good. Miles again. Make sure you label it as miles. Very nice. So now, no matter what number I give you, even if I give you like a really crazy decimal, you're able to just input it. And then once you have the equation, you don't really even need the graph anymore because you can look at that equation and get everything from there. Good. Okay, last 2, 3, and 4. The statement D of G equals 650 is actually asking you a question. What is the question that's being asked in the context of the given situation? D of G equals 650. What is that saying? What does that mean? Exactly, Carly. How many gallons do you need? How many G's do you need to get to 650 miles? Good. How many gallons needed to drive 650 miles? Okay, so letter B says, use the function you created for D of G to set up and solve an equation to answer the question you set above. So your equation was this over here. I'm gonna have to go to the side. D of G equals 30 times G plus 50. So I give you 650. Where does that get plugged in?
For what?
For the what? Good. So I'm going to plug it in right here. D of G is 650 equals 30G plus 50. And you know what this is right here? That's just an algebra problem that you want to solve, and you want to get G all by itself. So what should I do first?
Minus 50.
Minus the 50 from both sides. Good. You get 600 equals
50, I think.
30G. And then, yeah, what's the last step?
Divide.
Divide both sides by 30. Wait. G equals what?
I think it's 50.
It's not 50. It's 20. Good attempt, though. So, how many gallons do you need to drive 650 miles? You need 20 gallons. Good. So, once you write the equation, like I said, you should be able to solve for any piece of that equation. You should be able to solve for the gallons. You should be able to solve for the miles as well. Either way. Okay, last part, number 4. Why are there no negative inputs? So when I come over here to my independent and dependent variables, how come I don't have any negatives over here? Why am I starting at 0?
You can't go negative miles.
Well, is it talking about miles?
Yeah, you can't go negative.
Gallons, right. So your independent variable, it's not going to be negative because you can't have negative gallons, right? So that's my answer here. Why are there no negative inputs? Because there's no such thing as no negative gallons. Right, so in the context of this problem, that doesn't make sense. Can't have gallons that are negative. Okay, last part is domain and range. Now, your domain is your independent variable. It's your x variable. Domain is your independent. Range is your dependent. Or your y's. So this is your x's, these are your y's. I just want to know, how far can you go for your x's and how far can you go for your y's? So what's the smallest X value you can have and what's the largest X value you can have. So remember, our X's are talking about, they're talking about gallons. What's the smallest number of gallons you can have? 0. You can't have any negative numbers. What's the most number of gallons you could have? Actually, infinity. Why? Because once I use it up, then I add more to it, right? And it just keeps going, 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 going. So your domain is between 0 and infinity. It just goes on forever. When we write that, we write it like this. Your 0 is first. 0 is less than or equal to X. So that means X is bigger than 0 or equal to 0. And then it goes on until infinity. Infinity. So that means it's less than infinity, but greater than 0. So, less than infinity, greater than 0. Your range is your Y values. So your range is talking about your dependent, your number of miles. What's the smallest number of miles you can have? No. 50. The smallest number of miles in this problem is 50 because you can't go negative anymore. So wherever your 0 is, that's your smallest one. So your dependent is between 50, this is a Y, and how many miles can you drive? Is there a cap on that? Well, technically until your car dies, sure, but we would just put till infinity because it can go on forever and ever. I know. So we are finished with our notes. Good job, my dears. Tomorrow, we're going to do the back side of it. Okay? Tomorrow we'll do the back side. You guys did fantastic today. Thank you for being, bless you, being on task and answering the questions and working hard today. Stop recording.